Hi, in this video, I'll go over the concept behind a monotonous stack and how it can be used to solve problems of the nature of the problem next greater element. So starting off, monotonous stack is simply a stack that is designed in such a way that all its elements are either monotonically increasing or monotonically decreasing. For example, the stack 2, 3, 4, 5 would be a monotonically increasing stack. On the other hand, a stack such as 2, 3, 5, 4 is not a monotonous stack because its elements are neither monotonically increasing nor monotonically decreasing. So moving on to the next year element problem. And the simplest version of this problem is as follows. Here we are given two arrays without duplicates, nums1 and nums2, where nums1's elements are a subset of nums2. Our task is to find all the next year elements for nums1's elements in the corresponding places of nums2. The next greater number of a number x in nums1 is the first greater element to the right in nums2. And if it does not exist, then we output -1 for this number. So going over the example, consider the larger array 1, 3, 4, 2. In this case, the next greater element for the number 4 is -1 because there is no next greater element to the right of 4. The next greater element for 1 on the other hand is 3 because 3 is right next to 1 and it's greater than 1. Finally for 2, since there's no element to the right of 2, there is no next greater element, so we output -1 for 2 as well. So now going over the high level design of our code. So starting off, since our stack is empty, we first push 2 onto the stack. Next, since 1 is less than the value of the top of the stack, which is 2, we push 1 onto the stack, so our stack becomes 2 and then 1. Next, since our next element is 5, which is greater than 1, so since the current index 5 is greater than the value of the top of the stack, we pop 1 and we map 1 to 5. So 5 becomes the next greater element of 1. Similarly, now that the top of our stack points to 2 and 5 is still greater than 2, we map 2 to 5. Finally, since our stack is empty, we push 5 onto the stack. The next element we examine is 3. Since 3 is less than 5, we push 3 onto the stack, so our stack becomes 5 followed by 3. Our next element is 4, and since 4 is greater than the value of the top of the stack, which is currently 3, we pop 3 from the stack and we map 3 to 4, so 4 becomes the next greater element for 3. Next, we push 4 onto the stack. Finally, since we're done navigating through all the elements of nums1, we pop 4 and 5 from the stack and set their next greater element to -1 because there is no next greater element for these elements. So now looking at how the code for this is written out. So in order to store the next greater element for a given number, we use a map. So in this case, our hash map is called IDX. Starting off, so this is where the meat of the algorithm lies in this for loop. So initially, since our stack is empty, we check if the stack is empty, then we push the current element onto the stack and we continue with the for loop. This is the more interesting part, where if the stack is not empty and if the value at the top of the stack is less than the current element in nums2, then we map the top of the stack to nums2, to the current element of nums2. What that means is that for the value at the top of the stack, the next element is nums2 and index I. Then we pop the top of the stack to move on to the next value. And we continue doing this while either the stack is empty or we reach a point such that the value of s.top is greater than or equal to the value of nums2i. Finally, once we're done, we push the current element of nums2 onto the stack. Finally, once we're done examining all values of the array, we check for any remaining values in the stack. We pop them off and then map them to -1 because these values have no next greater element in the array. Once we're done, we can simply look back at the map to assign values to our vector. So for example, if you're looking at nums1, then we can just look at map with the key of 4, and that becomes the first value of a vector. So in this case, it'd be -1, and similarly, we can do that for all the values 1 and 2. And then the vector that we have at the end of this is the vector that we need for the output. So one variation of this problem is one where the array is circular. So the array 1, 3, 4, 2, instead of just ending at 2, it goes back to 1. So in that case, one way to do it would just be to append the array to itself. So the array becomes 1, 3, 4, 2, 1, 3, 4, 2, and then run the same process on that array which has twice the length. So these are two variations of the problem discussed on lead code, and this is how we can use a monotonous stack to solve the problem.